Hello, welcome back to AC Circuit Analysis. We're talking about three-phase circuits. The title of this lesson is Balanced Wye-Wye Analysis, the Neutral Voltage. Now let me just tell you before we jump into the circuit here that this lesson along with the next 3 to 4 lessons are really absolutely essential. The core concepts of balanced three-phase circuits are really contained in the next 4 lessons, including this one. After that, we'll solve a lot of problems and we'll apply it, but the theory behind it is really what you really have to understand. So I've broken up the concept of a three-phase circuit into, like I said, the next 3 or 4 lessons to kind of make sure you understand each little part of it. So I've kind of deconstructed what you might see in your book as maybe a couple of pages really, but I'm deconstructing it because it's crucial. Once you understand this stuff and you understand the rules of thumb and the other things that I'm going to teach you, then doing the problems just come like this and they all become the same after a while. So in this lesson, we're going to talk about the neutral voltage. And then the next lesson, we're going to talk about line currents and line voltages. And then we're going to learn about the relationship between the line currents and the line voltages. But we're starting our discussion. Remember, we talked about the fact that you can have a Y configuration for sources and loads. And then you can also have a delta configuration for sources and loads. And you can mix and match them. So you can have Y on the source and Y on the load. And you can have Y delta. And you can have delta for the source and delta for the load and delta Y. So those are the things we're going to cover in this class. But we're starting out with the most fundamental, most important one. And that is what we call Wye-Wye. So we have a basic Wye-Wye circuit on the board. I was tempted to draw this in real time as we discussed the lesson, but ultimately I think I would have bogged it down a little too much. So I've kind of got it on the board, but we're going to take some time to really make sure you understand and internalize what this is telling us. And then we're going to actually analyze this circuit with a node voltage equation. And we're going to get a conclusion at the end of it that's really the punchline of it. I could just give you the conclusion, but then you'd be robbed of understanding how we got it. So let's just kind of go through it here. What we have is we have 3 phases. We have an A phase. Notice everything in this black path is A. We have V-A-N, S-A. I'll explain what all these mean, but there's A's everywhere. And then we have a B phase, which is the source has a B. We have something here with a B, B, B. Everything there in blue has B's. And then we have the C phase, where everything has a C, right? And then we have this brown one, which is not a phase. It's actually the neutral. There that we talked about in the Wye-Wye configuration. We have a neutral conductor which taps into the center of where all the power supplies are connected, and it goes from the source to the load. All right, so we have a lot of stuff to talk about in this thing, but what I really want you to understand is I want you to look at this and slice it into 3 slices. First, we have this slice. Forget about everything over here. Just forget about it. Just look at this slice right here. What is this stuff? All the way up to where you see the labels here, we have a Y source. Now, in order to see that, you might have to turn your head sideways, kind of look at it like this. Forget about the boxes, forget about everything. Just look at the 3 sources, and if you kind of take this and kind of kink them up, then it looks like a Y. You have 2 sources coming in, joined at a common point, and then you have the third one kind of coming off as the bottom of the Y. So you have to look sideways, but this is a Y source. Later on, we'll draw a delta source. It'll look totally different than this. So basically, in order to identify if it's Y or delta, a Y source is going to have a common point where the power supplies, in this case we're looking only at the sources, are connected. So that's why the sources have the negative terminals. Notice how this one's written upside down, so the negative is toward the common point, negative toward the common point, negative toward the common point, and that goes back to how they're constructed. We talked about that in the previous lesson. All right, but anyway, everything here, this is sliced up as a source. Now notice that each source has a voltage, V-A-N. This is the voltage between little a, because there's little a in this circuit. Notice there's big A. So the way you need to think about this, all of these circuits are going to be drawn the same way. Little bitty letters are closer to the source, the lowercase letters. Capital letters are over toward the load. So you can see, just by writing down the voltage, V lowercase a, lowercase n, that is the voltage that goes essentially that's on this side of the circuit associated with terminal A toward terminal N. Lowercase n is the neutral right here, tapped in the center. So it's just telling you it's on the source side and it's between A and N. All right? Now notice that along this path, this A path here, we also have an impedance. This is the impedance of the source. Remember, every source, every real source has an impedance in the winding, right? Because they're all coils. So you have a resistance and usually an inductance associated with that.